Okay, good morning 11 Jotham. Welcome to our makeup class.
Good
On
morning
normal
po.
distribution, the Z table, and how we define the regions. So, here are the example of bell curve or normal curve. A normal distribution is also called as Gaussian distribution. Gaussian distribution is a continuous, symmetric, and bell-shaped distribution of a variable. Imagine you and your classmates taking a math test. Most students will get scores close to the average, while only a few will get really high or really low scores. This pattern forms a normal distribution or a Gaussian distribution because the data is balanced around the middle.
So, is the idle of the curve where most people's scores are?
Exactly. That the middle point is mean or average score in a perfect normal distribution. The mean, median, and mode are the same. So here are the properties of normal distribution. So let's explain each one of these properties. The first property in its simplest definition that states the middle curve is the average or the mean of a distribution. The second one is property is it's symmetrical or in the simplest terms both sides look the same. And the third one, the total area under the curve is equal to 1 or 100%. And for the first one, it it's very easy to understand. The curve can meet the x-axis, but they are never meant to touch. And now, the most important property is the empirical rule, where 68% of data falls within one standard deviation and 95% falls within two standard deviations and 99.7% falls within three standard deviations. Yes, Justin? Okay. Now, that's where the z-score and z-table come in. So, here here is the formula: value minus mean over standard deviation, and the x is the raw score or raw value, and the mean is the average, and the standard deviation, which is the spread of data. So, the z-score tells us how far a value is from the average in terms of standard deviation. If z equals to 0 and the value is exactly the average, if z is equal to 1, it is one standard deviation above the mean, and so on.
Can you show an easy example?
Okay, so let's say math test score, the average math test score is 75 and the standard deviation is 10. If a student scores 85, what is their z-score? So firstly, we will use the formula. You will substitute the x with 85 and the mean with 75 and the standard deviation with 10. So here's the formula. So let's distribute the raw score is 85 and the mean with 75 and the standard deviation is 10. So, who will give me the correct answer? Okay. Yes, Brandon.
Point 1, ma'am.
Correct. Now we look up to z the point 1 in the z table, which will give us. Yes, Cheryl.
0.8413 po.
And correct. Then we turn that into a percentage which will give us
84.13 po.
okay, count down. That is the correct answer. Now for the interpretation, this would mean that 84.13% of students scored below 85. So, for the interpretation, okay, Kiel,
What about students who scored above 85 po, ma'am?
What about them? Well, the total probability is 100 or zero point 0.1. So we subtract that 100 from the percentage we got. And the answer is the percentage we got is 84.13. So you'll subtract that on 100%. So what would be the answer? Okay, Justin and Kiel.
15.87%, sir. Ay, ma'am po.
So that would be the mean. 15.87% of the students scored above 85. So so let's proceed to the understanding regions in normal curve. So the left-tailed regions values less than certain z-score, and the right-tailed region values greater than a certain z-score. And the two-tailed region extreme values on both ends of the curve. So these regions can help us determine probabilities. For example, if you want to check if a test score is too low or too high, you look at the tails of the curve. Do you have any questions?
So, if we're testing if a score is really rare, we check the edges.
Exactly. If a score is far from the mean, it's considered unusual. In 95% confidence test, we keep 95% of data in the middle and leave 2.5% on each side for extreme values. So let's have a quick recap for the quarterly exam next week. So, the normal distribution is... Okay, Brandon?
A bell-shaped curve showing how data is spread.
And the z-score help us? That's correct, Brandon. And the next one, the z-score help us? Okay, Shaina?
Compare values to the average.
Okay, nice. And different regions of the curve. Okay, Cheryl.
Help us interpret data.
While the Z table help us to... Okay, Kiel, do you want to answer?
Find probabilities po.
Well, that would be all for today. Any final questions?
Nothing.
None po.
Well then, goodbye 11 Joseph. Good luck on your exams next week.
Bye, ma'am.
Bye,
Thank
ma'am.
you
Thank
po.
you.